laboratory experiment number 3. Okay, to find the partial derivatives and the Jacobian matrix for the given expression. Okay, here we can discuss with respect to the Python code which has to be used to find the partial derivatives and the Jacobian. Okay, here we are discussing with respect to the use of the Python Colab, okay, or else Jupyter, then MATLAB. Okay, among that I will discuss with respect to the Colab itself in online mode. Okay, the major objective is to understand this one is to find the partial derivative of the particular function with the several variables. Then Jacobian of a function with 2 and 3 variables. Okay, that we can consider. What is this partial derivative? Okay, if you are considering a particular function f of x and y, if you are going to make that differentiation with respect to the x as well as the y, okay, that itself is called as a what? Partial derivative functions. Okay, then Jacobian matrix is one which is to be used to make the proper evaluation for the multiple variable calculations which are to be present in the particular linear algebra expression. Okay, in this we are going to make use of this Jacobian matrix in many engineering applications to resolve the solution based on the requirement. Okay, here we are defining x is equal to g of uv and y is equal to h of uv. Then Jacobian matrix will be defined as dou of xy with respect to the dou of uv. Okay, one with respect to the x corresponding to the u. Okay, another is x with respect to the v, then y with respect to the x, then y with respect to the v. Okay, this is the evaluation of the individual component corresponding to the multivariable functionality itself is to be present. Okay, this type of solutions are itself is called as a what? The Jacobian matrices. Okay, this is also be a part of the partial derivatives. Okay, these things you can remember to make that evaluation. Okay, then we are going to make use of the multiple functionality to get the proper evaluation. Because of that reason, one function we are going to use matrix. Here we are going to define the number of variable parameter in the form of rows. Okay, row 1, row 2, row 3, like that. Then we need to determine the determinant of the particular matrices is to be defined. Okay, that matrix is what you defined will be taken into as a m. Then later we can get the determination, that is dt of m. Then you need to make the evaluation of the derivative function with respect to the particular variable. I need to define diff, then whatever the expression or the function is to be presented corresponds that what variable you are going to consider. Okay, this is one of the example to make the partial derivatives. Okay, with respect to that f of x and f of y. Okay, corresponds that the whatever the derivative functionality you need to get those parameters to be get evaluated. Okay, we can discuss one example. Okay, prove that mixed partial derivative uxy is equal to uyx for the expression u equal to exponential of x into x of cos y minus y of sin y. Okay, this is my expression u. For this, what I need to define? I need to make the differentiation with respect to the uxy and uyx. Then both are equal or not, I need to define. Whenever you need to do whether the derivation what you need to carry are equal or not, then I need to use what? If else condition. Okay, along with that, the whatever the libraries are to be presented, that I can utilize. Okay, that is I need to call the SymPy, the library. Okay, I need to import that to make my execution. Then what are that? In this expression they defined x and y are what? Variables. That is x, y are the variables. Those are to be representing as a symbols. So that I am representing x and the y. Both are small letters. Then u equal to, Okay, that is exponential of x into, okay, that is multiplied by x into cos of y minus y into sin of y. What is this? The input variable function u is equal to u of xy. Okay, this is what the expression. I need to make the partial derivatives both are to be equal or not. Then I am defining a variable dux. What I need to do? I need to differentiate u with respect to the x. Okay, whenever you are going to type this code, there is no necessity to type this one. You need to understand. That's why you are represented this comment. So that differentiate u with respect to the x. Then duy differentiate u with respect to the y. Okay, that is the what? The second expression. Then third one is what? I need to get two differential equations are to be a partial. So that dux can be differentiated with respect to the y. Okay, that is what? duxy. Differentiation of u with respect to the x and the y. Okay, so that we are getting with respect to that. Dux already we are derived. Then that we are differentiating with respect to the what? Y. That is to be represented here. Then duy with respect to the x. Differentiation with respect to that duy corresponding to the x. Okay, that we are going to get. What we need to find? Whether these two are equal or not, we have to find. To check that condition, we are defining if functionality. If duxy is equal to duyx, then whatever the expressions are there, mixed partial derivatives are equal. If these two are equal, it has to display this output. If not, it has to display mixed partial derivatives are not equal. Okay, this is the what? The code you need to execute. Okay, this is the what? The first example. What I need to do? Okay, I need to take this code and I have to type in the particular platform. You can use Jupyter, you can use Google Colab, you can use IDLE, or you can use Visual Basics, but corresponds to that libraries to be available. Okay, now I am proceeding with respect to the what? Google Colab. Google Colab I am searching. Then I will get the second one, that is Google Colab. I will click on it. Then I want to execute the new code. Okay, that is with respect to the what? Lab-03. So that I will go for new notebook. Once I used new notebook, I have to rename the file here. Once I renamed, then whatever my code is there, I need to type. Okay, without renaming, should not proceed for the execution of the code. What are the available? First, I am renaming the same lab 3. Today I am executing 05/11/2023. Okay, because of my reference point of view. Okay, then I need to type the code here. Okay, what I will do? I will take this code. Okay, because I need to know what is that example, so that I will keep this first comment whatever is to be presented. But I clearly told no need to type these comments itself during your execution, not at all be required. Okay, whenever you are going to type by yourself, kindly type only the code itself. Okay, remaining is not at all be required. Keep this is in mind. Once you did this, okay, then automatically that code will itself save. Then simply you go for run. Here it is the run cell, or else control enter. Then it will run that particular code itself. Then you will get the corresponding output, whether that derivatives are equal or not, because I need to make that equation what's to be defined are equal or not. Okay, now which it is showing that is mixed partial derivatives are equal. Whatever the expression I defined with respect to this expression, the partial derivatives are equal. Okay, this is what the expression is to be presented. Okay, keep this is in mind Then corresponds to that you make your explanation. When I want the next code, I have to click on this code. Okay, what is my next code? Directly I will take this code. Okay, I will explain their execution itself. Okay, you have to type this code. Okay, then what is this? Prove that u is equal to exponential of x into cos of y sine of y. Okay, I need to make u xx plus u y equal to 0. What it meant? Differentiation can be done with respect to the same variable twice. That is what u xx. U y what? U I need to differentiate with respect to the y twice. Okay, that is the what? The second derivative itself. So that x and y are what? Variables. Okay, so that I am taking that as a symbol. Then u is equal to exponential of x into cos of y minus y into sine of y. Okay, then display u. Whatever that expression is there, that has to appear. Then u, that is I need to make the u with respect to the x. So that differentiation of u x. Okay, u of x. Then differentiation of u with respect to the y. Dif u comma y. Then again I need to do the same expression with x variable itself. Dux with respect to the x. Then similar to that, duy with respect to the y. What I need to do? I need to add these two. That is uxx plus uyy. Okay, I need to add this. Then whether that answer is 0 or not, I have to verify. Okay, once I did, then I will run this code itself. It has to display. Okay, that is x cos y minus y sin y into e to the power of x. Okay, that is the exponential of x. This is only correct. E to the power of x, okay, into x cos y, then y sin y. Okay, this is my expression. Okay, that is expression. X into y, that is x into cos y, then y into sin y into e to the power of x. Okay, this is what the expression is to be presented. Okay, corresponding to this expression, you need to do the proper evaluation itself. Okay, this is the what the procedure is to be required. Then by adding these two, we are getting 0. That is the answer. Next, I want the new. I will go for new. I'll take the second. Okay, now to make the evaluation of the Jacobian matrix, what is to be presented, corresponding to that, the particular value, what is to be there. Okay, this Jacobian matrix is also be a part of what? The partial derivation. Okay, import SymPy is mandatory. Then here, how many parameters are there? X, Y, Z. So that X, Y, Z are to be taken as symbols. Then U is equal to what? X into Y into, that is divided by Z. Then V is equal to what? Y into Z divided by X. Then W is equal to what? Z into X divided by Y. What I need to do? I need to make the differential expressions because I need to want the Jacobian matrix. Okay, du with respect to the x, then du with respect to the y, du with respect to the z. Then similar to that, dv with respect to the x, dv with respect to the y. Okay, then dv with respect to the z. Similar to that, dw with respect to the x, dw with respect to the y, dw with respect to the z. Then I got the 9 parameter. Same thing I need to proceed forward the matrix representation point of view. So that I have to use a command matrix. What is my first row? First row element variables you have to represent. So that here du x, then du y, then du z. Second is what? Dvx, dvy, dvz. then dwx, dwy, dwz, which will be appeared in the form of matrices. So that I am using J equal to matrix. Then print the Jacobian matrix, whatever is to be present. Then display of J. What is this display? Whatever the expression after that complete evaluation to be done based on the differential expression to be displayed in the form of expressions. Because of that reason, we can use this display. Then later, I need to evaluate. What is that? Jacobian matrix determinant is equal to 4. So that JAC, this is what Jacobian. Okay, I am using that as a variable. DET is what? Determinant of what? Matrix J. Okay, that is matrix J. Dot do it. What is this do it? I need to make the evaluation of the determinant what to be defined in the matrix J. To carry that one do it function we are using. Then later we have to print the whatever the Jacobian matrix what is to be present. Okay, backslash n is what? To get new lines. Next line. Okay, because of that reason we are going to use the backslash n. Once you type this code, just you have to run. Got. Okay, what is this display? Display you need to get this particular expressions. What is this determinant of this Jacobian matrix? It is 4. This is 3 cross 3 matrix. Try to find with respect to that that is determinant of this expression. Then you are going to get that whatever the determinant value of that Jacobian matrix is there is 4. Next, I want new code. Okay, this is another expression to get the Jacobian matrix itself. Here also how many variables are there? Here is also 3 variables are to be present. Okay, but in this condition, the values are to be defined for the particular matrix. Okay, that value are to consider to get the particular expression what's to be presented. So that x, y, z, then you are defining u expression. Okay, then you are defining v expression. Then you are defining w expression. Okay, once you define this, then you have to make du of x, du of y, du of z, then dv of x, then dv of y, then dv of z, then dw of x, okay, then dw of y, then dw of z. Then I have to get that in the form of matrix, because whatever the expression I need to get, that to be there in the form of matrix. So that matrix I am going to use it. Then du of x, comma duy, then duz, then dvx, dvy, dvz, dwx, dwy, dwz. Okay, then I need to display that expression. Then what I need to do? I want the determinant. Okay, corresponds that what they defined. The Jacobian matrices values are to be defined as 1, minus 1, 0. At that instant, the print the value, whatever the values are to be present with respect to the particular Jacobian matrix, what you got. Okay, that will be get displayed here. Okay, whatever the determinant values are to be present. Then J1 is equal to J dot substitute. What I need to do? I need to substitute x is equal to 1, y equal to minus 1, z is equal to 0. For that, I need to get the particular value what's to be present. After getting that determinant itself, that I need to display that as a particular output. That will be taken as a GAC1 Jacobian for that modified value of 1, minus 1, 0. Then I'm going to execute. You got the values here. Okay, this is the what? The Jacobian matrix. So what's to be defined there? Okay, correspond to that expression. What to define? X is equal to value, you know, y is equal to value, then z is equal to value. Corresponds that of the 1, minus 1, 0. After that, we need to proceed for the what? The determination evaluation. Okay, after that, the expression what you are going to get is itself is the what? The substitute for the what? The Jacobian matrix, what you defined as a J1. Then I'm going to get this expression. For this, what is the value of this expression? Because this is the determinant expression. For this, I have to substitute what? 1 minus 1, 0. If you substituted that values, you will get answer as 20. This is how you need to proceed for the execution for the second example. Okay, similar to that, third. I will take this code. Then again I have to define the x parameter, y parameter, and the z parameter. Okay, because this is the pi. So that phi is the symbolical representation of that pi. Then the, okay, that is symbolical representation for theta. Okay, keep this is in mind. Then rho, which can be represented by rho. Okay, this is the what? The variable what you are going to define. Those are to be there with respect to that simple input. Okay, once you did that expression, you have to type corresponding to x, y, z. Okay, you are taken as here capital. Keep this is in mind. Then dx, then dy, dz. Again, what I need to do? dx1 I have to do, dy1 I have to do, then dz1 I have to do, dx2 I have to do, then dy2 I have to do, then dz2 I have to do. Okay, because the phi with respect to the theta with respect to the rho. Okay, because whenever you are going to do this derivative functionality, that will be taken into what? Your Jacobian matrix. J is equal to matrix. Okay, that is dx, dy, dz, dx1, dy1, dz1, dx2, dy2, dz2. Okay, this is what the representation which will be corresponds that of the particular expression was to be defined. Later I need to get that print the Jacobian matrix is display J. J is what? Your matrix. Okay, print. That is backslash and backslash n means we have to take the new line. Then later I will get the determinant, what is to be present. Simplifies the variable of the input, what you need to proceed for the what? Evaluation. Okay, this moment you can proceed with respect to the what? Simplify command to make that execution. Okay, once you did this typing, then you have to run. You got the expression. Because I need to display this theta and pi. Okay, and rho. Okay, these are the representation. Keep this in mind. Don't divide by yourself any variable. PHI is for phi, then THETA is for theta, RHO is for rho. Keep this in mind. Okay, these 5 codes are to be there to execute with respect to the Lab-03. Okay, once you go through the manual, proceed with that complete explanation was to be defined in the manual itself. Okay, then all the experiments are to be made the explanations properly. Once you go through that, the output need to be get verified. Okay, once you did your execution, what you need to do? You need to proceed for the writing of the record itself. Okay, MATLAB will discuss in the upcoming classes. Okay, with respect to that, all the Python codes are to be get completed. Okay, this moment you can discuss with respect to the MATLAB related code. But you have to write only that is Python procedure itself. Okay, what is your procedure? Open the Colab or the Jupyter for your Python program execution. Then type the code or program and save it. Then run the tool to obtain the result. Okay, this is the procedure. You have to remember this. Okay, then you have to write the result. Whatever output you got, that itself is what? The obtained partial derivatives and the Jacobian of the functions of several variables using Python programming is completed. We obtain that output itself. Okay, this is what? The lab number 3. Okay, if you have any doubt, then you can discuss in the regular offline classes.